Good morning, Algebra 2 students. For Mr. Fry, I'm looking at this 3-1 practice solving systems using tables and graphs. Actually, you're not using any tables and graphs. You're using the elimination method in order to figure out if these are consistent or independent. If you have not yet, watch the videos that Mr. Fry posted last week. That's where I got all this information. That's where I got my notes that I'm using in order to do this. There's a wonderful video of a lady that's walking through problems, and it's very calming and soothing, and you really should watch it and take some notes. It's very entertaining. But these are the notes that I got, and you could pause this and jot these down if you could read my writing. If you get one solution, it's consistent independent. If it's many solutions, you get consistent dependent. If it's no solution, you get inconsistent and independent. Okay, so some examples. One solution, if you get one answer for x and one answer for y, when you do this, that I'm going to show you here in a minute, that was an example of one solution. And no solution is if you get like two different answers, when you're working these out and it doesn't work out. Many solutions is if, they equal the same amount. And then that would tell you whether it's, these up here that I already read. So, then they give you examples using the elimination method. And here's an example of one solution. Here's a problem, and you could pause this if you need to. Here's an example of many solutions when you work it out. And here's an example of a problem that would be a no solution when you work it out. And these, like I said, came from that video, and just watch that video. This is going to be the first half. I'm just going to do 16 through 24, 22 I think it is right now, and I'm going to show you those, and then second half, just because these videos are easier to download once they're smaller. So we have these problems here that I'm dealing with, and I'm going to show you, I'm going to refer to my handwriting and my paper so that you can see what I'm doing with these. So 16. What I did was I manipulated that y equals 2x minus 3 so that it would be in standard form. So I brought the 2x over on this side. And then what I wanted to do is I wanted to manipulate it. So I multiplied this, all the terms in this problem down here, so that I could eliminate the y. So I have a plus y minus y. That's why I did that, okay? And I multiplied everything by -1. So in other words, -2x times a -1 is 2x. A plus y times a -1 would be a negative y. And the -3 times a -1 would be 3. Anyways, these y's eliminate. That's why I did it. And I get 2 plus 1x is 3x. 3 plus 3 is 6. Then I solve for x. I went ahead and plugged this 2 into the first one because that was the easier one. You could do either and you'll get the same answer. So I plugged this 2 in. 2 plus y equals 3. When I subtract both sides by 2, I get y equals 1. So I get one answer. I get 2, 1 as my answer. So that means it's consistent and independent. Where does that come from? From the notes, from that video, and from the notes that I took from that video, and the notes that I just showed you at the beginning of this video. Then I go down to 18. You can see I manipulated this second problem, and I ended up dividing everything by 2 so that I could eliminate my my x. Well, it happens to be that I end up eliminating everything, and it ends up being 0 equals 0. Well, that's many solutions from the notes, and that would be consistent and dependent. And then I go to number 20, and I manipulated the second problem by dividing everything by -3, each term divided by -3. And that way I was able to get rid of this. Well, it happens to be just like number 18, where it actually gets rid of everything. 3 minus 3, 9 minus 9. It ends up being 0 equals 0. That's another many solutions, and it's consistent and dependent. For number 22, I ended up manipulating the second problem by multiplying by a -1, and that changed it to this. And when I did that, I was able to get rid of the 3x minus 3, so that's why they call it the elimination method. So I'm now with -4y equals -8. I solve for y, my y becomes 2. I go ahead and plug 2 into, I've picked the first problem, this one right here. And so I end up working it out to where you could see I get the variable x by itself and x equals 1. So I get one answer. My answer, the coordinate would be 1, 2. That's where these two linear equations would be intersecting if I were to be graphing these. So that would be consistent and independent whenever you have one answer from the notes. Where did I get this? From the notes, from the video that you watched before and at the beginning of this video. I'll have the rest of this page posted here in a few minutes, and so good luck with the first half. Do the other ones on your own, and if you make mistakes, as long as you learn from them, you're making progress.